Okay, college algebra students. So to finish up this section, we looked at synthetic division and long division. So a couple of more topics that will revolve around synthetic division mostly. First thing we're going to look at is what we call the remainder theorem. And the remainder theorem basically just says if you divide a polynomial by some binomial, like you do a synthetic division, whatever the remainder is gives you the same thing as the function value. So I'm going to show this example right here to kind of give you an idea of what I mean by that. So to begin with, let's say you had this polynomial function right there. Okay, we know if you graphed this function, of course, it would kind of wiggle and look like that. And let's say that we wanted to find p of 2. You know, if x was 2, we want to find what the y value is. Well, the way we know how to do that currently is just plug the 2 in. So we'd have 2 to the third minus 4 times 2 squared minus 7 times 2 plus 10. So if we worked that out and worked out the arithmetic, we would have this. Okay, now I want to go ahead and do this on the calculator also here. And then we'll go over what the synthetic division does. So if I put this in, if you want to put this in your calculator, you can. There will be a couple of things that you'll be able to do on this remainder theorem. You'll be able to check your work pretty easily on your graphing calculator. Okay, so let's get this thing in here and just do the standard window. So I'll go zoom 6. Okay, that's what we have. Now, if you were to go to your table of values, by doing second graph, like I've shown you, you would find that this point 2, negative 2 shows up on here. So you have this point 2, negative 2. The other way you could do this is once you get your graph is you could just type the trace button, type the 2, and that would tell you what the function value is then. Okay. Now, what the remainder theorem tells you to do is it tells you really an alternative way to do this. So since we're evaluating at 2, we're going to use x minus 2. If I was wanting to find p of negative 2, then I would divide by x plus 2. So we're going to set this up with synthetic division. We're going to put the 2 out here, and then just put the coefficients. So we have 1, negative 4, negative 7, and 10, and then we'll do our synthetic division. Okay, so again, what we do is bring this down. 1 times 2 is 2. Add the column, that's negative 2. 2 times negative 2 is negative 4. Add the column, that's negative 11. Multiply, that's negative 22. And look at that, what do you notice? Okay, how about that? Isn't that amazing? So what you get is, if you do synthetic division, you get what that function value is. So that literally tells you that p of 2 is equal to negative 12. So what we're going to do on the remainder theorem is we're going to use that to determine function values. Okay, and ultimately this will lead up to being able to find zeros of polynomials. Okay, so if we go down to this example 5, let's go ahead and work this out. So we're going to take this polynomial function and we're going to find f of negative 1. So let's do it the algebraic way, which just means, okay, let's plug in that negative 1 in here. So we'll go ahead and do that. And that's going to give me negative 1 to the third. Okay, you're just multiplying a negative number out 3 times, so that's negative 1. If you take negative 1 squared, that gives positive 1. So you would end up getting this. See, that would cancel, it goes to 0. So you would end up with positive 3. Okay, so what you get is f of negative 1 turns out to be 3. That would be a point on that graph. Okay, so now we're going to do synthetic division. Okay, so if we do this now, you just take that number and you're going to use that in your synthetic division. So we take the negative 1, we write the coefficients. So we have a 1 for the x to the third. We have a 3 for x squared. Now we have a missing x, so we have to put a 0 there. So be careful about that. Then we have a 1. Okay, then we'll go down, do synthetic. Bring that down, multiply. That'll be negative 1. add the column, that's 2, multiply, that's -2, add the column, multiply, that would be 2, and then finally add that column to get 3. And that remainder right there is going to give you that function value then. Okay, so we conclude that f of -1 is equal to 3 by using the remainder theorem. So if you're doing work and stuff and I say use the remainder theorem to evaluate the function, I don't want to see this algebraically unless I want that algebraically. Remainder theorem, you need to show the synthetic division. So what happens on this problem is if you went through and graphed this function on a graphing calculator, all you're going to find on this is that, well, we have that point -1, 3, and that right there really is the remainder when you synthetically divide that then. Okay, so that's what you're doing on remainder theorem. Okay, all right, I'm going to move to the next stage here and just have you do one problem. We're not going to do a lot of problems on this, just kind of to get the idea, because we know how to do synthetic division now. So go ahead and pause the video and work this out. When you resume the video, like magic, you'll see the answers, okay? All right, hope you do well. Okay, so here's what you should have came up with. When you plug in the 2 and do this algebraically, you would do 2 times 2 to the third minus 3 times 2 squared plus 1. Work out the arithmetic, you would have got 5. Synthetic division, again, see how I set that up. The coefficients are 2, -3. There is not an x term there, so you had to put that 0 there. Then synthetically divide by 2. So again, just running through, bring the 2 down, multiply to get 4, add the column, 2 times 1 is 2, add the column to get 2, 2 times 2 is 4, add the column, you get the remainder. So again, what we find on this problem then is that the 0.25 is on the graph, and that 5 really represents the remainder after you do the synthetic division. Okay? All right, very good. All right, so let's move to the factor theorem, and this will be really a consequence of the remainder theorem, and this will be something that we use in the next section to actually figure out zeros of polynomials. So to begin with then, what will turn out on this factor theorem, it turns out really what happens is if the remainder is equal to 0, then you have a factor. You have found a factor of that polynomial. Okay, so that's how that's going to go. So what we're interested in is if we factored this polynomial, x squared minus 7x plus 12, we're interested in seeing if this is one of the factors of that polynomial. So what we do is we're going to do synthetic division of this. So we have coefficient of 1, we have a coefficient of -7, and 12. So we have a trinomial. And then what you do here is you're going to use the 3. Again, I want to stress if this was x plus 3, then you would use -3. The factors are always in the form x minus a. So if that's a minus sign, then you just use that. That's a plus sign, you use the opposite of that. So we're going to put the 3 there, then we'll do our synthetic division. So bring down the 1, 3 times 1 is 3, add the column to get -4, multiply to get -12. So what we have is we have a remainder of 0. So therefore we conclude that x minus 3 is a factor of x squared minus 7x plus 12. Okay, and here's the cool part of that too. I know you're interested in the cool part. Well, here's the other factor. So if we synthetically divide x squared, then this will really represent 1x, and that will represent -4. So what we find is not only is x minus 3 a factor, but x minus 4 is also a factor. Okay, so now I want you to see kind of what happens on this. If you were going to go through and factor this polynomial, And we've spent a lot of times just in different situations factoring polynomials. If we were to go through and factor this polynomial, well, what would we do? We would draw two parentheses on this. And so what I would have here is I would end up having x and x to get the x squared. I would have 3 times 4 to get the 12. And then I'd have to figure out the signs. So that would come together to make a 3x. The outer term would come together to make a 4x. And again, what we're trying to do is we're trying to make this middle term add up to negative 7x. Okay, so the way we make that happen is by having two negative signs there. Okay, so we would finish up by saying, okay, we need a minus 3 and a minus 4. So those inner and outer terms from the FOIL would give you negative 7x. So if you look at that, well, that's what the factors are. We had the x minus 3 that we proved by the synthetic division, and then we ended up with the x minus 4 like that. So what would happen on this problem is graphically, and I have the wrong graph on this. I don't know why I put this graph on here. That doesn't relate to this problem at all. So the factors are, there's only going to be two factors in this problem. You would just have the x minus 3 and the x minus 4. Okay, that is not the graph of that function. Here's what the graph looks like. So I want to go ahead and put that in. So I'll just put in the polynomial, which is a quadratic equation. So x squared minus 7x, and then plus 12. And if I do this in a standard window, graph that in a standard window, well, what we're going to have is you can see your zeros by tracing. So if you traced at 3, that would be one place where, see, the remainder is 0 right there. So that's an x-intercept. The other one is at 4. So that's what I wanted to show you on that. Okay, so you can use that graphing calculator to verify that you're right. It's real easy to do that. So this is what the graph should have looked like. I would recommend that you just scratch out that graph and sketch this one in its place, okay? And then maybe label that you have the 0.40 and you have the 0.30 like that, okay? And again, the zeros are the remainders coming from the synthetic division, okay? All right, so that's how you tell if something's a factor of a polynomial. All right, let's go to this next page. I'll do one more example, then I'll have you do a couple of examples yourself. So on example 6, we're just taking a given polynomial, and we're seeing if we're given a factor. So here's the polynomial function that we have. Here's the factor. We're going to test that. We're going to see if x minus 1 is a factor. So again, we just do synthetic division. So we'll have 2, 1, negative 16, and negative 8 as our coefficients. And again, we just use 1 because that is the form x minus something. Okay, so we're going to check and see what the remainder is. All right, so I bring down the 2, multiply the column to get 2, add the, 2 times 1 is 2, add the column to get 3, 1 times 3 is 3, add the column to get negative 13. This isn't looking good. 1 times negative 13 is negative 13. So it looks like our remainder on this is negative 21. Okay, so that would be a no because the remainder was not equal to 0. Okay, that's what you do. All right, and what you would find on this, if you looked at this graphically on your calculator, and I think it's always really good to relate the graphs of these things. If I put in 2x to the third, and then I put in plus x to the second, and minus 16x, minus 8, and if I put that in, I'm going to see that if I traced at 1, then that's the same remainder. Okay, so that is not a factor of that polynomial. Okay, next problem. What we're going to do on this is, it looks like I've given you this polynomial function, and we're going to check to see if x plus 5 is a factor using the factor theorem. So I'll put the coefficients. We have 1, 11, 41, 61, and 30. And then this time we're going to use -5. Okay, so we want to do that. Now go down and perform your synthetic division. So that comes straight down. Multiply, -5 times 1 is -5. Add the column, that will be 6. -5 times 6 is 30. Add the column, that's 11. -5 times 11 is -55. Add the column on that, and that will give you 6. -5 times 6 is 30, or -30 rather. So you have a remainder of 0. So that means, yes, that is a factor. And graphically on this problem, just one more time on this, I want you to see geometrically what's happening with this graph on here. So let me erase that. So we got x to the 4th, and then plus 11x to the 3rd, and then plus 41 x to the 2nd, plus 61x, plus 30. You're going to have a polynomial that has a degree of 4 with a leading coefficient of 1. The graph's going to kind of do something like that, like we've learned. Okay, we might not see a very good graph on this. Well, there we do. Okay, that did come out good. So notice if we trace it -5, the remainder is 0. So that ends up being represented by an x-intercept, a 0 of that polynomial. Okay, all right, very good. So go ahead and go down and pause the video, do these two problems, and just see if you get whether the given factor is a factor or not. And I think I made one little mistake on typing this up. This one you're trying to check that x plus 5 is a factor. This one you're trying to check that x minus 5 is a factor. Okay, so as soon as you're ready to check your answer, resume, and I'll have my answers posted. Okay, so here's the conclusions that hopefully you came up with on this one. So if you divide this by -5, you have to divide by -5 synthetically, you do end up with a remainder of 0, so that tells you that that is a factor of that polynomial. The next thing would be on this one, you had to put that 0 there. This has a missing x squared term, so if you forgot to do that, you need to correct that. And then we divide by 5. After I did that, I got a remainder of 125, which is not 0, so that's a no. All right, so that's what you should have come up with on that, just kind of an easy application of synthetic division. Okay, on this last problem, we have a graph of a polynomial, and this is a third-degree polynomial on this. I'm telling you that. You kind of see that it has the type of endpoint behavior we would expect for a third-degree polynomial to have with a positive leading coefficient. So what I'm telling you on this is that this is a factor of this given polynomial like that. Okay, so what we need to do is do this. First of all, if you take this factor, x squared plus 3x minus 4, this thing factors. And what you're going to see on this is you can see that there are 3 different zeros on here. So this would be, let's see, 1, 2, 3, 4, 5, 6. That's x equals 6. This right here would be at x equals 1. And then this one would be at x equals -4 on that. Okay. Whoops, -1, -4. Okay, so we got that. So what I'm going to go ahead and do, let's see if this thing factors right here. Because we want to find this third-degree polynomial, given that this is a factor here. So if we factored this polynomial, the first term would be x and x. The last term would be 1 and 4. And again, we'd have to bring this together and kind of figure out how the signs go. Okay, we're wanting this to add up to that middle term of 3x. So that would tell us that we would need to have a positive 4 and a -1 in order for the 1 and 4 4 minus 1 would be 3x. So what this would be is if you have x minus 1, that would translate to that 0 of x equals 1. If we have the factor x plus 4, that would translate to that other 0 of negative 4 like that. So really all we got to do on this is by looking at the graph here is we just got to put in this other 0 here. So what we have really is we have the structure of this polynomial is x minus 1, x plus 4, that was given, and then we have to tack on this other factor of x minus 6. Okay, so we just have to multiply this out, and then we got the answer. Now, we already were given this. See, when you multiply that out, that was what we were given. So you can FOIL that out if you want to, but you're going to get this anyway. So what we need to do on this problem is just multiply that out, and then we'll have what the graph of that polynomial is. Okay, so when I do this, I'm just going to multiply x squared times x is going to give x to the third. X squared times negative 6 is going to be negative 6x squared. Then 3x times x is positive 3x squared. 3x times negative 6 is negative 18x. Negative 4 times x is negative 4x. Negative 4 times negative 6 is plus 24. All right, so what we're going to have then is our polynomial. We would have x to the third. We've got some like terms we can put together. And then we'd have this plus 24. So what we would get is our polynomial function would be this thing. Okay, so just by giving that one factor in that graph, and really I didn't even have to give you that factor. I mean, you can take a graph of a polynomial, and if you see what the zeros are, you can set it up, and then you can find out what that polynomial is. So that would be the answer to the problem. The other thing I'd recommend, if you're doing homework and you're seeing a problem like that and you're having a hard time getting your answer, well, you can tell you're right on this then. Okay, so if I just plug in my answer and graph it, so I've got x to the third and then minus 3x squared and minus 22x plus 24, and if I graph that, it's going to be the same graph, essentially. Now, if I change my window a little bit on this, and if I go maybe change the y's to something like, I don't know, negative 40 to 40 or something like that, maybe scale that by 10, it'll look a little bit more like the graph I gave you, because this is a graph that's scaled on here. All right, but the key thing on here is notice that if you go to your table of values, you're going to see all these zeros. 1, 0, we have that. That translates to that factor. We have negative 4, 0. That translates to the factor x plus 4. And then 6, 0 is on there. So that translates to that factor. So that checks graphically that it's the same graph. Okay, that'll wrap up this section then. Thanks for watching, and good luck with your division skills. Cheers.